Alright, you're welcome once again to another exciting chemistry lesson. Now, in today's video, we're going to be talking about IUPAC nomenclature of the alkenes. So, it's an organic chemistry concept, alright? IUPAC nomenclature of alkenes. Now, before you understand this IUPAC nomenclature of alkenes, please, I have made a video explaining IUPAC nomenclature of alkenes. Alright, so if you're watching this on YouTube, please do it to just go and look at my catalog of videos and you see IUPAC nomenclature of alkenes. If you're watching this on TikTok or on Facebook, you can run to my bio where there is a link to my YouTube channel, so you watch the video on how to name alkenes. Alright, so now let's look at alkenes. Now, in trying to name alkenes, in alkenes, I told you guys that whenever you want to name a hydrocarbon, all right, you must find the parent chain, the longest continuous chain, which personally I consider to be the superior rule, all right. But there's nothing like the superior rule, but I just feel being able to identify the parent chain is one of the most important steps in IUPAC nomenclature. All right, so now in alkanes without functional group, all right, any direction can give us the parent chain, but in alkenes and alkynes with functional group, not any direction give us the parent chain. Now, for the alkenes, to get our parent chain for the alkenes, all right, the parent chain is the longest carbon chain carrying the double bond. Are you with me? So, to identify your parent chain for the alkenes, please take note that the parent chain must carry the double bond. All right. So when you are trying to get the longest continuous chain, which is the parent chain, all right, when you are trying to get the longest carbon chain, make sure that the longest carbon chain is the one that is carrying the double bond. All right, make sure it's the one that is carrying the double bond. And sometimes, for some questions I have seen, all right, there are some that the parent chain is not actually the longest, but it's just that the parent chain is the one that carries the double bond. All right, so that is it. So please, this is the main thing. If you can understand this, then every other part is very, 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 very much easy. All right, so now every other thing holds the same. Follow alphabetical order, follow numbering patterns. All right, give the lowest number to the substituents and all of those stuff. So those other things apply. Now let's look at question 1. Let's get our hands on question 1. Now for question 1, let us identify the parent chain first. Now the parent chain is the longest carbon chain carrying the double bond. So we can go like this. 1, 2. We cannot go like 1, 2, 3 because it does not involve the double bond. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So the longest we can get from all way around is 8. All right, so I choose to go this way. All right, let's go like this. So these are parent chain. Now those groups not part of the parent chain, they are called what? Substituent. So substituent, and what? Substituent. All right, so now time for the numbering. Now another thing again, you need to also take note for the alkenes, the numbering system. Please give the least possible number to the carbon with the double bond. Give the least possible number to the carbon with the double bond. So you want to give the least possible number to the carbon with the double bond. That is what we are doing. The least possible number to the carbon with the double bond. So that means when we are numbering, we are trying to make sure that these two carbons that is carrying the double bond must have the least possible number. All right. So we cannot start our 1 from here. We cannot start with 1, 2, 3, 4, 5, 6, 7, 8. So this will be having 7 and 8 too big. But rather we'll start our 1 from here. So it's gonna be 1, 2, 3, 4, 5, 6, 7, and 8. So that means our double bond, the carbons carrying the double bond is what? 2 and 3. Carbon 2 and 3. Now, between 2 and 3, all right, between 2 and 3, which one is smaller? Is 2. So we will not just say that the double bond is carried by carbon 2, all right, because between 2 and 3, 2 is smaller. So there's a 2-step you have to do here, all right. First of all, you give the 2 carbons, all right, that contains the double bond the least possible number, and then between those 2 carbons, you will now look which one has the smallest number between those 2 carbons. So the smallest number is the one you will now go with as being the carbon that is carrying the double bond. So between 2 and 3, the smallest number is 2. So therefore 2 is the number that is carrying what? The double bond. So now we have our parent chain is simply now what? Oct 2 in. Alright, that's our parent chain, oct 2 in. Alright, that's what we have got in oct 2 in. Now let us add our substituents. So from our numbering system, we discover that the first substituent is on carbon 2, the second substituent is on carbon 6, and the third substituent is on carbon 7. So hence, our substituent is now what? 2, 6, 7. Are you getting it? 2, 6, 7. 2, 6, 7. Now, methyl. So now we have 2, 6, 7. Trimethyl oct 2 in. So this becomes our answer. 2, 6, 7. Trimethyl oct 2 in. 2, 6, 7. Trimethyl oct 2 in. Now, let us look at question 2. Now, let us answer question 2. Question 2 is the IUPAC name for CH3, CH2, CH, double bond, CH, CH, CH3 in brackets, and all of this. Now, this compound is a condensed compound. There are things I call condensed compounds. Now, why do I call them condensed compounds? Because these compounds are not fully shown. Some of the things are not fully shown. And in order for you to properly name compound like this, you need to open those things in brackets. You need to properly arrange the compound the way it is so that you can see every possible substituent and every possible length, carbon length. So you'll be able to determine the parent chain right and the substituent right. Okay, so first of all, you need to decondense this structure. So by decondensing this structure, you have CH3, CH2, CH, double bond, CH, CH. Here we now have CH3, then CH2, then CH, C2H5. So we can write this. Alright, we're going to open this C2H5. So here it will be CH2, CH3. This is what we have as C2H5. So 2 carbon, 2 plus 3, 5. So CH. Alright, so we are going to open this guy. So hydrogen is here. Then one CH3 is here. Another CH3 is here. How am I so sure that there are 2 CH3? Because of these 2 in bracket. These 2 CH3 in bracket and 2. That's the thing that there are 2 CH3 and then this 1 H. So this is the open form of this guy. Now let us identify our parent chain. Remember, the parent chain must carry the double bond. Alright, so the parent chain is the longest carbon chain. Alright, that consists of what? The double bond. Okay, so now let us go. Let's start our numbering. Let's try to give the least possible number. Remember, once we discover our parent chain, then we'll give the least possible number to the 2 carbons that houses the double bond. And then after we've given the least possible number to those 2 carbons, between those 2 carbons, we'll pick the one with the lesser number to carry the double bond. Alright, so now let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so we can get 9 in so many ways. Okay, we can get 9 in so many ways. let's say it's 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So, but I would like to go like this. I would like to take it like this. Straight. Straight will still give us 9. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means this guy is a substituent, this guy is a substituent, this guy is a substituent. That's all. So we have 3 substituents. So now let us start our numbering. Now do we start our 1 from here? No. Because if we start our 1 from here, that'll be 1, 2, 3, 4, 5, 6. So we now have 6, 7. But we start our 1 from here. 1, 2, 3, 4. So now be 3, 4. So which direction we give the carbons with the double bond, alright, a smaller number is this numbering direction. So I don't know. Start our 1 from here. So this is our 1. Okay, let me just put it down. 1, 2, this 3, 4, 5, 6, 7, 8, 9. Alright. So between 3 and 4, which one is smaller? 3. So therefore, our parent chain is now non-3. That's our parent chain. Now let us identify our substituents. Now we have carbon 5. So at carbon 5, we have a methyl substituent, 5 methyl. At carbon 7, we have an ethyl substituent, 7 ethyl. And at carbon 8, we have what? Another methyl group. So another methyl. So now, let us put this. So we are having substituents that are of different groups. We have 2 that are methyl, 1 is an ethyl. So how do we now put this? This is where we are going to follow alphabetical order. So you count A, B, C, D, E. I've gotten E, which stands for ethyl, ethyl. Then E, F, G, H, I, J, K, L, M. So E comes before M. So we are going to write our ethyl group before the methyl. So we'll now start. The name of this compound will now be 7 ethyl, 5, 8 dimethyl, non-serine. 7 ethyl, 5, 8 dimethyl, non-serine. That becomes our answer to this compound. All right. Now, please take note that numbers are separated from numbers by a comma. All right, by a comma. Okay, that's why I separate 5, 8. I use a comma. Then numbers are separated from alphabet by hyphen. So that's why 7 I put hyphen. Between L and 5 I put hyphen. Between 8 and D I put hyphen. So to separate number from letters, we use hyphen. To separate numbers from numbers, we use comma. Alright, so this is what we have. Now, let's take it a little bit higher. Alright, take for example, you are given this structure of alkenes drawn like this. Now, this type of structure is what we call the line or skeletal structure. Now, how do I know that this is an alkene, this is an alkene? How do I know? Because there are double bonds. You can see double bond here, you can see double bond here. So these are what students mostly encounter, especially students in the A level, all right, in colleges and universities. This is the kind of structure that they actually see most times. All right, now what I just need to tell you is that whenever you see a structure like this, don't panic. Just know that each junction is a carbon. Each junction is a carbon. All right, so I already highlighted it here for you to see. So this is a junction, one carbon, another junction, carbon, 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 carbon. All right, so at each junction there is a carbon. Okay, so you can also do that for this guy, this second one. So there's a carbon here, there's a carbon here, here's another junction, there's a carbon here, there's a carbon here, carbon and carbon. So now first of all, let us find our parent chain, the longest, right? So in getting the longest, we have 1, 2, 3, 4, 5, 6. All right, so this 6, it carries the double bond. So the correct number, we want to give the least possible number to the carbons with the double bond. So the best we can get the least possible number is to start at 1 from here, because start numbering from here 1. 1, 2, 3, 4, 5, 6. Wrong, but 1, 2, 3, 4, 5, 6 is better. So 1, 2, 3, 4, 5, 6. Now, so we have given our parents in there. This guy is a substituent. This guy is a substituent. Now, between B, bromine starts with B, and chlorine starts with C. Between B and C, which one comes first alphabetically? It is B. So, in naming this compound, it will now be 5-bromo, 2-chloro. Then, you can see the double bond is in between carbon 1 and 2. Now, between 2 and 1, which one is smaller? 1. So, we give the double bond to carbon 1. So, we now have, now remember the parent chain is what? Hexene, alright, that's eggs, 6. Now the eggs what now? Eggs, because the double bond is at carbon 1, now say eggs 1 in, or we can write it as 5-bromo, 2-chloro, hexene. Eggs 1 in is still the same thing as hexene. Now, for the second compound, now this guy, I want to get the parent chain. So the longest carrying the double bond. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'll just want us to go with this guy, this pattern here. So 1, 2, 3, 4, 5. So this guy is a substituent, precisely a methyl substituent. So when you see only one carbon, alright, only one carbon is a methyl substituent. When you see 2 carbons, ethyl substituent. When you see 3 carbons, propyl substituent. Alright, so remember our substituent, this our methyl substituent is at what? Carbon 2. Alright, so that's 2 methyl because the substituent is at what? Carbon 2, 2 methyl. So to now name this, we have what? 2 methyl. Now, our double bond is in between carbon 2 and what? 3. In between carbon 2 and 3. So between 2 and 3, which one is smaller? The answer is what? 2. That will be 2 methyl. Remember the parent chain is 1, 2, 3, 4, 5. Pent. So that's 2 methyl. The double bond is at carbon 2. It will now be 2 methyl pent 2 in. So this is the name of this compound and this is the name of this compound. So thank you very much for watching this video lesson. If you are seeing this video on YouTube, please remember to subscribe, share and like. Drop a comment. Then if you are seeing this video on Facebook or TikTok at Master Lectures, you can do well to follow and also share to your friends, like as well. Alright. So on Facebook it is Master Lectures with a space. So Master then space lectures. Then on TikTok it is Master Lectures, no space. Then on YouTube it is Master Science Guide. So thank you very much for watching this video lesson. If you want the link to my YouTube channel, visit my bio and I'll see you in the next video.